For centuries, scientists have been trying to unlock the mysteries behind the power of lightning. Even Charles Darwin wrote about it. Now USF researchers are using a new approach to study lightning, not by looking up at the sky, but by looking down at the Florida sand and a small clue a lightning bolt can leave behind. In his own words, here's Dr. Matthew Pasek.
What happens is the electricity hits that sand and heats it up really, really hot. We're talking 50,000 degrees Fahrenheit, hotter than anything we can see on the surface of the earth, hotter than the surface of the sun. So it heats it up, it vaporizes, completely vaporizes the rock and melts another portion of the rock. And that happens very fast, and then it sits there and cools down, forming a glass. And the glass that gets left over by the lightning is called a fulgurite. This fulgurite probably formed on the order of 1/1,000,000th of a second. So extremely fast time period to make a fulgurite. It could have done so 1,000 years ago, 1,000,000 years ago, 10 days ago, yesterday, especially here in Florida where we have so much lightning. They are hollow because the interior is where the actual lightning was. So lightning was traveling through the fulgurite and vaporized the sand that was inside of it. Lightning, it turns out, has small amounts of energy and it can have really big amounts of energy. And so in the case of understanding how much energy there is, one of the ways of going about it is by looking at the fulgurites. And we can see how big the biggest lightning strikes actually are. Based on how thick they are, how thick the fulgurite is, we can get an idea of how much energy each lightning strike actually gave to the ground. And so you can imagine that a bigger fulgurite means that there's more energy that got put into the sand. A smaller one means that there was less. We still don't exactly know why lightning strikes. And so this may not help too much with understanding that, but it does give us another idea of how much energy and maybe power a lightning strike might have.